Discrete Math Introduction to Proofs Part 2. So we're going to solve the exercise. So prove that if n is equals to a times b, where a and b are positive integers, then a is less than or equals to square root of n, or b is less than or equals to square root of n. First off, we have a choice. We could use the discussed direct proof and the other method, which is the proof by contraposition. So if we analyze the problem, we have the hypothesis. So the hypothesis is this one. If n is the product is equals to the product of a and b, then you have this disjunction. So a less than or equals to square root of n, or b is less than or equals to square root of n. The problem with this is, if this is a disjunction, there are three possible cases where this statement is true. That means if the first statement is false, the second statement is true. So that's one case. The other case is first statement is true, the other is false. And finally, when the first statement is true and the second statement is also true. This ends up in a problem because in analysis, somehow we need to pinpoint a certain truth value. So when it comes to disjunction, there's an inherent ambiguity by virtue of this multiple cases. So as much as possible, we will try to avoid conjunction. So therefore, it's only natural to incline to the proof by contraposition in this case, because if we're going to if this is initially P implying Q, then if proof by contraposition is used, we're going to use or produce the NAT of the Q implying P. So in that case, implying NAT P. So in that case, I'm going to apply De Morgan's theorem for Q. So therefore, this will become, if A, so that is less than or equals to, so if A is greater than square root of n, and this or now will become and by De Morgan's theorem. So and A, you have less than, or no, it's greater than square root of n. And there is only one case where this statement is true. Since this is now conjunction, we know that this is only true if both of these statements are true. So that's only one case, and it's easy to manipulate. So then n is equals to AB. So if this is contraposition, the NAT of this will be not equal to AB. So we have now produced the contraposition of the original theorem. So if we prove the contraposition, since they are logically equivalent, then we end up with the proof of the original theorem. So let's go into prove this one. So if this is true, so first step, will be to assume truth. Assume your hypothesis is true. So therefore, this statement, a greater than square root of n and a greater than, or sorry, this is supposed to be b. So b is greater than square root of n. So this is supposed to be true. So therefore, first statement is true, second statement is also true, and that's only one case. So second step, I have to show now that the conclusion is also true. What is the conclusion? So the conclusion is n is not equals to a times b, where ab are positive integers. So in that case, I could simply produce the a times b. So assuming that this equation is already true and the second equation is also true, so let this be equation, say this equation 1, and then the second one is equation 2. So if I multiply the two, multiplying equation 1 by equation 2, so I will get a times b, so that is greater than square root of n times square root of n. And if I simplify that, this is a, b is greater than n. And if we check again our conclusion that we are trying to prove, this n is not equals to ab, and this is exactly it. This is exactly telling us that n is less than ab. In that case, n is not equals to ab. So therefore, the conclusion is true, and that proves the theorem.